This is lesson 2.3. You should be on page 80, and this lesson is subtracting real numbers. Now, the last lesson was adding real numbers, so I think it makes sense that we should be addressing subtraction now. This first paragraph is a good summary of what we need to be thinking when we come across subtraction problems, with positive and real numbers. Think about the problem 12 minus 3. 12 minus 3, I'm pretty sure you're up top of your head, you're probably getting, yeah, that's 9. And now think about 12 plus negative 3. I hope you're getting 9 out of that too. Do you notice they're giving you the same value? So with that said, you can conclude that 12 minus 3 and 12 plus negative 3, both those processes gave you the same answer. Subtracting 3 from 12 is equivalent to adding the opposite of 3 to 12. This is an example of the subtraction rule. This rule we have to know if you're going to be good at subtracting positive and negative numbers, and then the key thing here, without a calculator. Because when you do the homework, and I'll just put without calculator again here, when you do the homework, when you take a test over this quiz or over this stuff, it's going to be no calculator, all right? So we definitely want to be well-versed in this rule as you practice the homework. Here's what this rule says. To subtract B from A, add the opposite of B to A. Now, if you're sitting there and you're like, what the heck's that? Okay, let's put numbers in there. Let's say, instead of B and A, let's put 6 and 10. To subtract 6 from 10, well, let's do 6 from 10. Answer would be 4, right? If I subtract 6 from 10. This rule is saying to subtract 6 from 10, add the opposite of 6 to 10. So let's take 10 and let's add the opposite of 6. Does it make sense? You still get 4. Now, the first question I always get from students is, Mr. Lemansky, why would I want to do that for 10 minus 6? That's easy. 10 minus 6 is 4. I've done that since 3rd grade. Why would you want to complicate this? I'm not trying to complicate it, but here's why you have to know the rule. For the problems where the subtraction is both positive numbers, you probably don't need that rule. But what if it's a problem like this where we have negatives involved? This now becomes a headache if you don't understand the rule. Let's follow this rule for this problem. Negative 12 minus 19. Well, instead of subtracting, I'm going to take negative 12 and I'm going to follow the rule. I'm going to add the opposite of 19, which is negative 19. Well, this should be easy, and this is lesson 2.2 material now. I got the same sign, so I'll forget the sign for a minute. 12 plus 19 is 31, and since these both were negative, I'll put a negative in front. The answer is negative 31. You notice how I ended up doing the same thing I did the other day. So the nice thing about this method is now instead of having to teach you a whole bunch of new stuff, I'm like, hey, if you just change the problem from subtraction to addition, if you add the opposite, you're doing the same things you just did in the other day's homework, and now we're just getting better at it because we're doing the same stuff each day. All right? Let's look at this one. 18 minus negative 7. Well, I'm not going to try to figure that out. I'm going to follow this rule. I'm going to do 18. I'm going to add the opposite of negative 7, which is positive 7, and 18 plus 7 is 25. Well, it couldn't have got any easier than that. Okay? This is an incredibly important rule. Let's practice a few. Find the difference. Negative 2 minus 7. Well, I'm going to do negative 2, and I'm going to add the opposite of 7, which is negative 7. Well, that should be easy. Negative 9. 2 and 7 add up to 9. Put a negative in front. This one, 11.7 minus negative 5. I'm not going to do that. I'm going to do 11.7, and I'm going to add the opposite of that, which is 5. Well, heck, that's easy. It's 16.7. And here, 1/3 minus a half. Well, I should do 1/3 plus negative a half. Well, remember in our last lesson when we add with different signs, I should subtract, so I'm going to have to get a common denominator. Let's do 6. This would be 2/6 here. This would be 3/6 here. So 3/6 minus 2/6 is 1/6. And since the half is the bigger amount, 3/6 is bigger than 2/6, and that was negative, I know my answer is negative 1/6. So if we understand this rule, that when we subtract, we want to add the opposite of B to A, it's going to make a lot of these problems a lot less difficult, and without a calculator, we want less difficult. In the homework, they're going to have you evaluate a variable expression. You have to be careful on these, okay? So when you see y minus x plus 6.8, you got to take 7.2 for y and plug it in. You got to take negative 2 for x and plug it in. And then let's rewrite this out. I have 7.2 minus the negative 2 plus 6.8. Look what they do here. I'm not going to subtract. I'm going to follow this rule. I'm going to change this to 7.2 plus 2 plus 6.8. Now, you're not using a calculator, so I have a little suggestion for you. I'm going to use the commutative property. I'll put CP. We learned this in lesson 2.2. I can change the order of adding. Since I'm adding everything, I'm going to add these two together first because that's easy. 7.2 plus 6.8 is 14. And then I can add the 2 on at the end and get 16. This is why these rules and these properties you learned in the last lesson are important from lesson 2.2. If you know you can rearrange the order, I can make this into a much simpler problem than doing 7.2 plus 2, which is 9.2, and then trying to figure out 9.2 plus 6.8, for example. Okay? One last thing here. Evaluating change. It's important you understand. When you read the word change in a problem, that's a subtraction. Change is asking for you to subtract. And you'll notice in the homework, they will have story problems and word problems, and you notice here's a sample one. What was the change in temperature? So you can see in the work here, they end up doing a subtraction because that's what change is asking for. Change is a subtraction. Let's just do a few practice problems here, and then we'll let you get going on the homework. So evaluate x minus y plus 8. You notice x is negative 3 and y is 5.2. So I should do negative 3 minus y was 5.2 plus 8. I'm not subtracting. I'm going to add. I'm going to use that rule we learned today. Negative 3, I'll add the opposite of 5.2 plus 8. And now I can do this in any order I want. I think it's probably just fine to do this first. I got negative 8.2. Remember, same sign. Add the numbers up. 3 and 5.2 is 8.2, and these were negative. So negative 8.2 plus 8. And if the signs are different and I'm adding, I can subtract real quick, drop the signs, line up my decimal. Does it make sense how I'm getting 0.2 out of that? And since the bigger number was negative, it's got to be a negative 0.2. So that's the answer for number 4. Or this one. I have 5.2 minus open parenthesis x, which is negative 3 minus 2. Okay? Well, I got to do it in parentheses first. I'll use the rule that I just learned. Negative 3, I'm adding the opposite of 2. Well, negative 3 plus negative 2, that should be a negative 5. So I have 5.2 minus negative 5. And I'm not going to subtract. I'm going to use the rule we learned today. 5.2, and I'm going to add the opposite amount. 5.2 plus 5 is 10.2. That would be the answer to number 5. Okay? You can try number 6 on your own, and you can look that up on the answer key. Car values. A new car is valued at $15,000. 1 year later, the car is valued at $12,300. What is the change in the value of the car? Okay, well, minus 12,300 is what I need to do. That would be $2,700. Okay. The change would be the value. I should designate a direction. The price, maybe I should write this, the price dropped, or the value dropped $2,700. Okay. So that's the end of this video. If you have any questions, just make sure you ask in class.